Hello and welcome to Module 6 for ED 584. So we'll go ahead and we will get started. I'll share my screen. There you go. There's a screen. The picture I'm sharing is of the Washington Monument. I took this, it was taken actually from the Lincoln Memorial, looking east toward the Washington Monument back in November of 2014 and in the fall. And good picture, beautiful day in DC when I took the picture. So let's go ahead, we'll get going. This module serves as a review and an expansion upon our study of t-test statistical analysis methods. In the previous modules, we have examined t-test methods that are used to test hypotheses addressing group differences associated with a measured variable that is continuous data. The one independent sample t-test, sometimes, and it can be referred to as the one sample t-test, allow us to determine whether the population mean of interest is equal to a hypothesized value, which was the test mean. Like all statistical procedures, there are certain assumptions that should be met to obtain valid information. For the one sample t-test, these assumptions are that the data in the population being sampled is normally distributed, that the selection of the sampled data occurs in a random fashion, and that the probability of each measured outcome is independent. Random sampling usually ensures that the assumption of independence has been satisfied. The term robustness is sometimes used to describe the extent to which a statistical method provides valid results, even when the statistical assumptions of the test are not perfectly met. The point at which the results are valid versus invalid is not always clear and may require the researcher to make informed decisions as to whether or not the analysis procedure in question is appropriate for the situation. It is worth noting that the one independent sample t-test method is fairly robust to violations of normality assumptions when sample sizes are equal to or greater than 30. Robust meaning that the method produces valid results even when the assumption is not very well met. We have also examined the related samples t-test, and this is sometimes referred to as dependent samples. This test allows us to test hypotheses related to differences between two populations in which a participant in one population sample is related to a participant in the other sample. They may or may not be the same participant, and that's repeated measures or match pair design. Assumptions are that the population of different scores are normally distributed and there is independence within groups. A more obvious assumption is that the two samples should be of equal size, as the term related samples implies. Like the one independent samples t-test, it is robust to violations of normality when sample sizes are 30 or more. One potential application of this method is the analysis of a randomized pretest post-test design. And you can see that design here in Canvas. Another potential application of this method is the analysis of a non-randomized pretest post-test design. In other words, what would be referred to as a quasi-experimental pretest post-test design. The design notations would look like the following, and there, see that. In addition, the two independent sample t-test is used to test hypotheses concerning the differences between two population means. Assumptions are normality. Data in each population being sampled is normally distributed. Random sampling, each of the two samples was collected through some random selection process. Independence, probability of each measurement is independent from other measures, and equal variances, that the variances of each population is equal to each other. The equal variance assumption can be tested through the use of an F-test. SPSS also provides a feature to test for the assumptions of equal variances. In cases where equal variances cannot be shown between two groups, there is a form of the two independent sample t-test that can be used to account for this violation. There are various examples of when a two independent sample t-test would be appropriate. One of them is the randomized post-test only design. Interestingly, this relative simple design is one of the strongest in terms of internal validity. And you see there the randomized post-test only design. Hypothesis testing using t-tests represents a way to compare means between two groups when the data being collected is continuous data. Point estimation and confidence interval estimation is an alternative method that allows us to estimate population parameters within identified bounds based on desired probability level. Hypothesis testing using two independent sample t-tests and the alternative point estimation and interval estimation approach are important to understand. So here are the objectives for this learning module. Then we're going to go down into the readings, and we need to reflect on the fact that t-tests can be used in either experimental or non-experimental situations. In the case of experimental research, we are concerned with making causal claims. The populations being investigated are hypothetical and based on random assignment to groups, with one group receiving one form of a treatment and the other group receiving another or no treatment at all, comparison or control group. In this case, these groups represent hypothetical populations, and equivalence of the groups has been ensured through random assignment to groups. A two-group post-test only design is a very good candidate for the use of the two independent sample t-tests when examining causality. A non-experimental design can be used to compare and examine real populations to see if they are different from each other. Causality cannot be established, but we can establish if the groups are the same or not. In a non-experimental design, we take a random sample from each population, and then compare these samples. It is through random selection and random assignment that the inferential statistical procedures we are examining allow us to validly infer our findings to that of the population and help to establish external validity. That is to make claims about populations from our data sample. Ensuring random sampling or random assignments does require work by the researcher to establish a protocol of some form of randomness. Experimental designs are based on random assignment, which ensures randomness and are good candidates for the use of the t-test when comparing two groups. Quasi-experimental designs, a form of causal research design that does not rely upon random assignment, but rather uses some form of convenient sample or intact group, can also be analyzed with the t-test. Although these types of designs can sometimes require more sophisticated approaches to statistical analysis than the t-test. Thus, sometimes there are trade-offs a researcher can invest the time into research design that ensures randomness and then be able to use fairly straightforward methods of analysis, such as a t-test, or they can choose to use convenience samples, quasi-experimental designs, which might require more work put into the statistical procedure. Consider your own research interest. Consider groups that might be investigated and compared. Consider the variable to be measured and reflect on the level of measurement the data must be in order for it to be appropriate for the t-test. In review, there are 4 levels of measurement, and they are nominal, ordinal, interval, and scale. Okay, so the readings, the assigned readings for this module from the statistics for the behavioral sciences, it's really a review of chapters 9, 10, and 11, and then with how to use SPSS, section 6.3, independent sample t-tests, and appendix A, effect size. Then there is the reflective commentary, for Module 6, and then go ahead and begin working on assignment 2, and this will be due during Module 7. And this assignment 2 addresses chapters 8 through 11 in the SBS textbook, and you will it's in Canvas, and then you will upload it to Canvas when you submit that. Then as we look ahead to the next module, Module 7, at this point, we have examined statistical methods that can be used to compare two groups. Now we are going to be looking at how to compare 3 or more groups. In such a situation, we use a procedure known as the analysis of variance, or ANOVA. And this will be the next topic that we go into, and feel free to move ahead to Chapter 12 and the one-way between subjects ANOVA. And that concludes the introduction and instructions for Module 6. As always, if you have any questions, do not hesitate to let me know, and we'll talk to you later. Take care.